Happy? All right. I'm really bad at coming up with titles for talks. That's what came out of my mouth when I was sitting there, well, on my fingers when I was sitting there typing it up, and I never updated it. So I just usually run with whatever came out first. This is what lighting IPv6 on a network looks like from the perspective of a service provider. That's really the important point here is I'm not coming at this from how do I get my servers to operate. I'm coming at this from the angle of how do I get my network to handle IPv6. And this isn't a technical talk. This is not actually about technology. This is largely a story of all of the bumps, bruises, and other things I stumbled over on the way of doing this. Because I am not a genius, and I am still learning this. If you've never met me before, my name's Jeff Goeke-Smith. I apparently build networks for a living. I did not set out intending to do this, but I'm definitely doing it now. For the last 10 years, yeah, actually it's been a full 10 years now, I've worked for Michigan State University, building, operating networks, operating the stuff on networks, operating security devices that are accused of working on networks. I built probably one of the most unreasonable IPS and firewall deployments I've ever seen anywhere. It is in fact possible to run 5 gigabits of IPS in 2007. To do this, you have to do a number of absolutely horrible things. I invented some of them on the way. Let's just say there was source-based routing involved, and it went downhill from there. Officially, I will gladly talk about all sorts of stupid things I have seen done or done with a network. I am, in fact, not only capable of breaking networks, that's easy, I'm capable of breaking network engineers, and sometimes I can even do it over the phone. I am responsible for building the packet cyclotron as a mechanism to generate 10 gigabits of test traffic. Turns out it works pretty well. I've been doing the network at NOTACON for 3 years now, but I've been here since NOTACON 1. Thus, if you've been around for a while, I'm probably familiar looking. And I'm going to point out, I have never actually done a talk at NOTACON about my day jobs. This is the first time. This is, in fact, my day job. So I work for Michigan State University. That means something to those of us who work there. It means something to those of us who've heard of it. We have a nasty habit of getting into the Big Ten championships of various things. But what does it mean from the perspective of a network? Well, we have 60,000 users on campus. If you want to talk about it, total number of users worldwide, it's, well, okay, I think it's 250,000 email accounts last time we checked. Actually getting a number like that out of the system's rather difficult. I have 100,000 active MAC addresses on campus every day. And I have switches that have to maintain 100,000 MAC addresses in memory. We have a /13 of IPv4 space. We will probably have a /12 of IPv4 space before we're said and done. Turns out, so I'll take this opportunity. This talk is designed to go sort of sideways at any moment. In fact, it's designed where I just go wandering off on a topic every now and then. Turns out we're not under IP pressure. Not under IPv4 pressure at all. MSU is a founding member of something called Merit. Merit existed before that whole, we're going to move away from Class A, Class B, and Class C and go to CIDR. Actually, I think it predates Aaron. Merit has an entire /8, most of which is not utilized, and they aren't planning on giving it back anytime soon. It is very possible that I will be growing into a /12 before I'm done with the IPv4 stuff, which frankly I'd like to be done with as soon as possible, but that's not going to happen. Our campus is 6 square miles, almost all of it covered by fiber, usually in the order of tens to hundreds of fibers per building, and I'm under fiber pressure so great that I'm using bidirectional optics in my network. This is how much data is flowing across that campus. It's actually, I like to think of it more like sloshing back and forth, because that's pretty much what happens. You give people enough network and they stop caring about where they are physically, which is cool that they can stop caring where they are physically, but it's sort of a challenge in the opposite side, which is they want to move arbitrary amounts of data over your network at any moment. And we do have a global presence. I have run networks. Well, okay, the worst one was Dubai. We decided to put a teaching facility in Dubai. I don't understand why, not by call. And then I got informed I'm supporting a network in Dubai. By the way, Jeff, do you have your passport? No, I don't. Darn, we won't pay for you to get one. Yeah, there was a lot of interesting of a year worth of trying to run a network in a country that is hostile to the idea of cryptography crossing their borders. So, stories back there too. Okay, so this is the network I run. This is stuff connected to my network. I'm literally not making any of this up. I have the phones, the alarms, the door locks, and the HVAC. That's any big network. We do have a television station. They have a tendency to stream stuff all the time. There's a particle accelerator. Yes, connected through exactly one firewall isolating the two. There is a particle accelerator connected to the network. Not making that up. We have medical facilities, so occasionally, I find out about people who are plugging MRIs into the network. It's just like, Ethernet. Could you think about that a little bit before you do it? Okay. We also have dorms. I have somewhere between 10,000 and 13,000 students who call our campus home, which means I have all of the problems of a residential ISP without any of the infrastructure to do it. Pavilion for livestock. Yes, hung off of SkyPilot Wireless, hung off the back end of the campus. We have an entire livestock judging pavilion. This one I'm now guessing at, but I'm pretty sure we have Wi-Fi instrumented livestock. Can't point at where they keep them, but I'm pretty sure they actually exist. We also have a Center for Performing Arts. Wharton Center is a huge stage, and there's all sorts of entertaining problems that show up when you have traveling shows of people showing up to do a performance for a week and then are gone again. The other problem, which is entertaining in the same category, is, and intermission happens and everybody snaps out their smartphone. Several thousand people in a room, all in visual sight of each other that want the network to work at once. And, oh yeah, Big Ten. Mentioned we do championships and that sort of thing. They like to blow uncompressed HD across my network. That's interesting. Challenging with a firewall and an IPS, I might know. Okay, so this talks about IPv6. This is not, in fact, the only thing I'm doing. This is one of many flaming razor-sharp bowling balls that we keep juggling in the air at any given time. I started thinking about IPv6 in 2003. And I mean literally just thinking about how do we do this. In 2007, the organization started going, this could be a problem. We need to figure it out. In 2007, we had a router per building. The concept of building is not as distinct as one might hope, but roughly a router per building. All stuffed in a single OSPF area, all happily rolling along just fine. IPv4 only. We had VLANs that were only local to the building. VLANs did not go anywhere except the building. Attempting to cross the VLAN bound or trying to cross VLAN boundaries, not possible. You go through a router. You have to do layer 3. And the entire backbone was a single gigabit backbone. Typically on campus, you were seeing 7 to 8 hops to get across the campus. That was before you hit what might be considered the internet. At the time, I got put in charge of running the intrusion prevention system at the internet border. I'm going to ask, who here knows what an intrusion prevention system is? Okay, for everybody else, It is antivirus jammed in at the network layer operating at line speed. It's an intrusion detection system that's been handed a shotgun to shoot packets in the head on the way by. It has been renamed by some members of my organization as the Internet Prevention System. I was the primary guy who got the call, "Did you break the network today?" And I had to get very good at explaining, no, and here's the packet trace that proves it. Your thing's just broken. Other parts that we had to pay attention to. Consistently over the last 20, 25 years, our network's been around that long, we have seen 30% growth in aggregate traffic per year. And if you haven't stared at what an exponential number looks like, my graphs go screaming off into terabits. And it's sort of like, how are we going to handle that? And the answer is, we hope to figure that out by the time we get there. Other things I should point out. This is a university network. We operate on a very open network policy. If it moves IP addresses, or if it moves IP, we should support it. If it has an Ethernet jack, it should be able to be connected. Those are about the limits of what we say can't exist on the network. It has to have an Ethernet jack. It has to speak IP. Beyond that, we're supposed to make it work somehow. This has led to a lot of very interesting decisions. Ask me about that general space later. So, 2007, we look at this network and we say, okay, the hardware supports IPv6. Manufacturer even was on the spec sheet, we support IPv6. Find out what that means. It's probably not what you're thinking. The hardware we had supported IPv6, do just fine handling IPv6, as long as every single packet that you wanted to move was fine going up to the CPU and being forwarded in CPU only. Had no hardware accelerated path at all. This is actually okay for a megabit or two. Turns out the mechanism that the gear we were using at the time operated on was something called flow-based forwarding. The first packet of a given flow, which was defined by endpoint information, would be sent through the CPU. It would actually do real routing, and then that fingerprint would be jammed down into a hardware forwarding table, at which point the next packet would match the forwarding table and it would just be sent on its way in hardware. This meant that the first packet of every flow hit the CPU as well. Turns out we do enough traffic that's short and small that we had a significant portion of our traffic already running in the CPU. Adding IPv6 wasn't going to fly. No, this means things like DNS. Every single DNS request is a separate flow. Small packets destroy your networking hardware. Okay, so you have to start thinking about this a really long way out. We organizationally started thinking about it 5 years ago. I started thinking about it nearly a decade ago. And this has to be a hardware cycle, because you're going to probably have to forklift major chunks of the hardware to get to the point where you're happy. See the load balancers couldn't find any load balancers that spoke IPv6 for less than 15,000? Yeah, same general problem space, and it doesn't really matter how much money you can bring to the table, because if you can bring that much, you need more. And when I say maybe two, I do mean literally two. The first one might not work out so well for you. It didn't for us. I'm going to leave that down the memory hole and just jump to where we got. So I got asked up. It wasn't just me. It was a task force of 3 or 4 people. We sat down and tried to figure out, how do we upgrade the network? And IPv6 was on that list. Can you see where it was on that list? We got asked to make the network go faster, because go faster always looks good. Note, we measure speed in megabit. We don't talk about latency that much. We really ought to. We need to figure out how to do that as an industry. We also got asked to virtualize the network. I got asked at point blank, how do we make it so that any arbitrary port on the entire campus, remember, 6 square miles, can be on any VLAN with another computer on any other arbitrary port on the same VLAN? on the same VLAN, same layer 2 on any arbitrary 2 ports across the entire campus. Okay. Oh yeah, we'd like you to put big firewalls in there so that we can put a firewall between 2 arbitrary points on the network. And while you're at it, could you fix the redundancy issues? And yeah, that IPv6 thing, can you support that as well? Okay. Let's see what we came up with. So we did it. We came up with a design which does this. It is a 10 gig backbone. It is one massive layer 2 cloud. I have 5,000 switches in a single layer 2 cloud. 2,500 plus VLANs, and we're burning through about 3 VLANs a week right now, building out new stuff. Q&Q is in our future just to handle the number of VLANs we're handling. It is collapsed. The other people have described this as a hyper-collapsed core network. We have one router, one. It is very, very big. And when I say very, very big, there's a reason I wear steel-toe boots. You don't want to drop it on your foot. You won't get the foot back. I have a single rack which pulls 12,000 watts peak. It is a switch. A switch. Yes, sir. OpenFlow is possible to do on some of the hardware. OpenFlow is a different rant, not one I'm covering in this talk. If you would like to hear that rant, I will be around all weekend. Yes, this is entirely traditional. The vendor supplied the software that forwards the packets. And trust me, you want the vendor supplying the software that forwards the packets. It's a lot easier to debug because you will be debugging it. Yeah. So I make a point of not really covering the vendors for a reason. It's actually opposite reasons than you might think. My employer is concerned that I might inadvertently endorse them. The vendors are concerned I'll actually tell you what happened when I did it. Here's the deal. I'll put this here now. These are my own opinions. These are not those of my employer, however much I might want them to be. We used to be running Foundry gear. We're now primarily running Juniper gear in our core. We have, and I'm not making this up as a list, Juniper, Cisco, HP, Foundry, Extreme, and probably Lucent hardware in our network today, included in that pile of 5,000 switches and routers and firewalls and IPSs and everything else under the planet. We operate on lowest bidder promise, which meant, and you have to remember, when I say you have to start a hardware cycle out, I work for a university. Hardware cycles might be 15 or 20 years. I still have 10 base 2 deployed. Yep. I didn't really specify what form of Ethernet jack, did I? There's a reason. Oh yeah, I also run a CMTS. No, I don't know why. It's on its 5th year of what I think was a 3-year total length of the deploy. Cable modem systems are fun too. I try not to think about that. I do not have a DSLAM. I refuse to believe I have a DSLAM. One big firewall and IPS. Yes, we do in fact run an IPS still. We run, at last count, 6.5 gigabits of fully inspected traffic. So a regular expression engine that eats 6.5 gigabits and wins most of the time. Right, so deploying IPv6, what this talk was actually supposed to be about, but I had to set context. Old network. Yeah, no, we're not doing that. New network. This should work. And that's really where I started, which was, this should work. There are configs on the internet. No, you aren't going to see any configs in here. Go look on the internet. They're as wrong as they were when I started. So first step, we were talking about Aaron earlier, go get addresses. So addresses. That involves paperwork, which actually in our case involves confusion. because our addresses come from a time before Aaron. So it's sort of like, who are you and why are you talking to us? But we have IP addresses, not in our list. We're that old. We don't simply have a lot of the justification documents which many people have had to write. So it's sort of like, what do you mean justification? Oh, okay, write justification. More paperwork. Verify justification is okay with everybody else. More paperwork. Hey, there's a contract here we have to sign. Lawyer. Then we go to the lawyers. Lawyers look at it and go, yeah, we don't like this. Negotiations, more paperwork. 6 months pass. Timers expire. Yeah, we aren't going to do that. But you're, okay, we'll sign this anyway. Yes, but that's now expired. So we get to go back to the start of the process and do paperwork and ask for justification. This process actually takes a while. Particularly worse in our case. I quote a friend of mine who runs an ISP. Yeah, I don't know what your problem is. I just copied and pasted the justification paper for the IPv4 stuff. We don't have any of that. We never did it. But eventually, you get through the entire process. Addresses. Great. You know what addresses do on their own? Absolutely nothing. Now you got to go route the addresses. This involves going to whoever you talk to for networking. MSU is lucky. We have exactly one upstream. This makes a lot of it easier. They're called Merit. We covered them earlier. And then you try and figure out how to establish BGP relationship. Okay, this takes a while. This is on a whole pile of hardware and configurations you don't touch every day for a reason. It's dangerous. If you get it wrong, you lose the entire network. It takes a little bit of downtime, a whole bunch of configuration, and a lot of scratching your head going, what? How is this wired? But then there's a next step, which is actually as much fun as anything else. It only took us one morning to get that change in place. Then we had to wait for all of our upstream's peers to learn our addresses, not through BGP. They learned those instantly because they were advertised. But then you have to wait for their administrative engine to allow those addresses to be advertised from that peer. This can take weeks to months, depending on how fast it grinds through the process. I suspect we're still having problems in that form today, as our addresses are not permitted to be imported into the neighbors' tables yet. But this took a week or two. We got mostly to the point we could talk to Google. Google, okay, that's like what, 10% of internet traffic today, so that's a significant portion. We can move down the road. So I'm going to talk about maintenance windows for a second. Maintenance windows are your friends, because the phrase maintenance window means the network may not exist. You try not to do that too much, but if you say maintenance window, all of a sudden, and the universe inverted itself. Sorry, we'll put it back by 7 a.m. It'll be great. You actually really, really like maintenance windows because people can't yell at you for what happened in them. Interesting aside of this, the maintenance windows for a university are not the same maintenance windows for everybody else. Our traffic tapers off at about 4:30 in the morning. That's where we see minimum utilization, which is only a gigabit or two. From about 5 a.m. to 7 a.m. is when we're allowed to play with stuff. That's the slow time in the network. Maintenance windows are your enemies. Maintenance windows don't come around every day. They don't come around often. And they're usually filled with other things going on, which isn't this clearly ridiculous thing that nobody really needs, right? You have to watch out for stepping on other people doing work in the same maintenance window. You have to make sure that the network is still functional for them during it. And that might mean I get a maintenance window to do IPv6 stuff exclusively about once a month. And I get an hour. Do it as fast as humanly possible. The last bit, which we'll be getting to, if you don't have a change management process, invent one. Go buy somebody else's. Ask them to make one for you. You want change management in here. You want the ability to roll back whatever you did, because it will eventually be in such a state that you will be going, oh God, put it back, put it back, put it back. Okay, so I've made it to the point my core network actually has IPv6 addresses. Note, This process of doing so, I've skipped over the entire process of teaching the firewalls how to handle IPv6, the IPSs how to handle IPv6, and all of the switches how to ignore the existence of IPv6. Because if they aren't specifically set up to handle IPv6, you don't want them getting creative with it. Okay, stage one. Plug my desk in and make it work. This is easy. There's no firewalls, or if there are firewalls, they're firewalls I run. This is all my own networking hardware. It's nobody else's. I'm not crossing an administrative boundary. It's not any significant challenge, and I'm not even doing auto-config. I'm going to do static. This should be type in the address and it works, right? So first thing I stumbled into, if you're doing static assignment of IPv6 addresses, and Windows 7 was my test platform, you can't not have an IPv6 name server. It requires one. It simply will not commit the config without it. Maybe this is my environment. Maybe I'm doing it wrong. Maybe I've missed something. I'm not a Windows expert, but Second thing, this is going to come back and bite me repeatedly. Typing addresses is shockingly hard. Getting them typed right is shockingly hard. And nothing works, and there are no diagnostics if you get it wrong. So, in plus 2.1, make an IPv6 name server. IPv6 name server had to be built, and I had to go build it. Okay, this is survivable, right? Straightforward. But I'm not allowed to put it under my desk because we have policies. Servers don't go in your cubicle, which means that now I have to enable IPv6 in our data center, which has a firewall, which everything goes through. And thus, maintenance windows are your enemy. You get one a month. So that threw a wrench in the entire process of walking down and doing, it's like 5 minutes. Boot the name server, install the name server, turn on recursive, tell it that it can recurse, you're done, right? No. Month. Okay, back to step in plus 2 where we were just a minute ago. Get all of it typed in correctly. And hey, IPv6chicken.com works. It's great. It has a picture of a chicken, tells you whether IPv6 is working. That's all it does. Done. This was easy. This is simple. This is straightforward. Everybody should have already done this. Okay, so I'm going to go talk about subnet size again, because this is entertaining. At this point, I have now done multiple presentations to my campus, and I get a consistent series of questions which are entertaining in the context of subnet size. And I'm going to walk through a couple of the arguments quickly because they're pretty hilarious. 1, 64 subnets means you can put as many people in the subnet as you want, right? So all of MSU is going to be a single /64. I'm hearing the realization of what that means echoing around the room. Yes. I have had to have this argument repeatedly. I have a number of people who are extremely interested in conserving IP space and want to make absolutely certain that we don't use too much of it. So we're going to put all of MSU in a single subnet. Well, technically, I could probably swing that today. The switches would have shot me before I got done doing it because the switches don't have enough space in their CAM tables to forward that many MAC addresses. This breaks down in a number of other levels as well. Turns out broadcast domains break down at 2,000 to 3,000 computers in a subnet. I know this experimentally. I call them dorms. We have had to break dorms in half and then half again as people showed up with more stuff because we don't have any prohibition against plugging another switch into the wall on your dorm room and hanging as much stuff as you want off of it and collecting as many public IPs as you want. By the way, NAT is evil. NAT is horrible. I have found exactly one instance in the world where NAT improves the situation. The punchline is it's the instance that was covered in the previous talk, which was AT&T GSM phones, their microcells, forwarding stuff. Turns out using NAT is also a trigger to tell it to go into stateful firewall traversal mode. Did not know this. Found this out by reading somebody else's packet trace. Okay, so here's the interesting thing. Okay, so I'm going to take an aside from my aside here for a moment. Remember I said I work for Michigan State University and we've existed before Aaron? Yeah, we have a lot of history that we have to deal with. I was going to say just, but it's not really just. It's really our history. It's not really undue because it was done for good reasons at the time. As it stands today on our campus, we still support a proxy ARP-enabled /13 subnet setting for all the edge hosts. There, I'll let that sink in for a second. Yeah, the blinking, yes. You can claim that you're on our /13 and the routers will clean the mess up on the way by. The fact is, at one point, it literally was a /13. This was when we had one router. It was also probably the mid-'80s. The first router on campus got the address of .3 because the mainframe was on .1 and the microframe was on .2. There's a lot of history. So the concept of shoving all of the machines on a single subnet is what people actually believe is still happening on our campus. It hasn't been that way in a long time. We generally don't do anything bigger than a /20. Yes, you heard that right, a /20 on a single layer 2. Proxy ARP cleans it up and makes it look like it can be a single /13. We are undoing this bit by bit as it breaks other stuff, namely firewalls. Back to subnets. So an interesting problem here is, yes, it turns out on IPv6, the way it's constructed with multicast, with appropriately built switches, with NDP and all of the other stuff, yeah, you actually can put probably 10 or 20,000 machines on a single layer 2 and have it work right if it's a pure IPv6 network. This is because IPv6 multicast encodes part of your MAC address in the multicast address, which means smart switches could filter it if they knew how to, if they had been trained to, which means that you won't have to absorb the entire load of all of the broadcast traffic across the network because it's all multicast and semi-directed, not fully directed. As long as you're still running IPv4, not true. Still have to run upper limit of a couple thousand machines on a single subnet. If we get to the day where IPv6 only networks exist, you might be able to do something entertaining like that. Some people predict IPv4, 10 years, 20 years. At present rate, I'm guessing the scientific instrumentation watching the heat death of the universe will be running IPv4. Still? Guess. Okay, so back to step in 1+1. Find out what you broke. You might remember step in +1 being the one where I actually got routing established to all of my upstreams, and we broke stuff on the way. Didn't find out for 2 weeks. So we thought we tested this. We have a test track where we can actually set up the vast majority of our config, light it, see what happens, and actually find out if it's going to work or not. But that morning in the haze at 5 a.m. as we're sitting there typing away madly at this thing, running the scripts that we'd pre-built, it started saying, failure to commit. Can't use this rate limiting filter. And we're going, huh? Okay, fine. It's a rate limiter that limits how much broadcast traffic can come into the router at any given time. Okay, fine. We'll run without one for a while. We'll rip it out and we'll figure out why the heck that's happening later. IPv6 must happen because we were actually getting management push at this point. Okay, so we just ripped the filters out. Cool. That shouldn't be a problem, right? Lower default filters kicked in, which don't have any warning, nor any trace in the config file, nor any indication that they happened. You just happen to have to know they were there. Now, this is broadcast rate limiting filters. ARP is broadcast. So let's talk about ARP for a second. ARP is for IPv4. It's the thing that turns an IP address into a MAC address so your Ethernet card can actually speak Ethernet. This is an important section. It almost always happens below the radar. Nearly nobody who doesn't have to run a large network ever interacts with this Unless, of course, you're at a hostile security conference and people ask you to set a static ARP entry. And then they just give you the string, you type it in, and everything happens, and you move on with life. As an infrastructure service provider, I have to deal with ARP on a regular basis because it's usually wrong, at least by the time I'm dealing with ARP. You don't have an ARP response, don't have an ARP entry, I don't care how your IP stack is configured, there is no way it's talking to the network. So, problem continues. It turns out throwing away a substantial part of ARP traffic doesn't break nearly as many things as you might note. We figure we were throwing away about 10% of the ARP traffic on our network, and it mostly worked just fine. We got a couple of complaints of it was lagged a little or it was slow, but nothing really substantial. And this was for about 10 days. It's really resilient to no response. It tries to get an updated ARP entry before the existing one expires, so if it misses 1 or 2 a cycle, but it can get it 3 or 4 seconds later, generally everything keeps working. But a different group had a routing element, which was actually a firewall as well, which added to the complexity of finding this, had decided to set an ARP timeout on this device to 5 seconds. 5 seconds of ARP timeout with the throwing away about 1 out of 10 ARPs results in this thing losing an ARP entry to its upstream router every 20 to 30 seconds for a couple of seconds. This does nothing for throughput. This destroys things. The default is about 15 minutes, at which point we went and asked the question, why did you do this? Well, the consultant did it. Okay, why was the consultant messing with this setting? There was a load balancer involved, which wasn't doing MAC address sharing, had separate MAC addresses on both sides. So the solution was to go to the router and say, check for a new MAC address every 5 seconds. Not just for that load balancer, but the whole network, everything. So we fixed that and put our router, or improved rate limits back in, and got back to actually getting work done. So let's talk about the config that broke on us. Device modes. I'm stumbling into these more and more often. It happens all the time. A feature sheet will list 1,000 different things that the device can do. It turns out often it can only do about 2 of them at the same time. In this case, we had set one of the feature modes to allow us to apply Ethernet filters and treat nearly every interface like it was actually Ethernet. It lets us config stuff simpler because we're actually routing IP, but we were applying Ethernet filters to various sections of the config. This actually let us build a lot simpler of a configuration in the first place, but we needed BGP support in IPv6. See, we're trying to light IPv6. Lighting that feature required us to turn off feature set A, at all of a sudden our filters were no longer applicable. Okay, and that feature set was part of our failover mechanism. Remember how I said we had a router and a backup? Yes, this was how the backup did some of its work. Okay, so the problem's hard to find. When I say hard to find, the error message leads you in the wrong direction, thinking it has something to do with filters as opposed to which interfaces the filters are applied to. It's in a huge configuration. One router, entire campus, 20 to 30,000 lines of configuration, not mechanically generated. And we ended up fixing this by adding even more configuration, another 500 lines, to appropriately solve applying and removing the filters as we shifted from primary to secondary status. So, more config, it'll be great. Make sure your hardware can do everything you want it to do and do it all at the same time. This is actually a consistent story in me building networks and the stuff I've run into. Pretty consistently, the hardware will do each and every feature I want it to on its own. But if you try and turn on all the knobs at once, well, things start snapping off at high speed. And then you don't know what happened. Make sure you test whatever it is you're buying in a full configuration and figure out how to throw enough load at it that it might vaguely approximate your real world. I have no spare MSU I can spin up and load. I really wish I did. It'd make testing a lot of the stuff I do easier, but there is absolutely no way to simulate the effect of 12,000 students in dorms. I have no idea how to build a test case for that. Okay, so made it to my desk, fixed everything we broke, made it to the point of let's open up our beta program to the campus and say, would you like to use IPv6? We're going to do beta. And we aren't going to do DHCPv6 or Slack at all. Static addressing only. You actually have to type in all these addresses. This is a good thing. This is a good thing because it acts as a filter to slow down people who want the newest, greatest thing and say, turn it on, it'll be great. You want people to move slowly into this and with intent, not randomly go charging in. So back to /64. Yes, sir. Email, and that's their problem, not mine. I'm a service provider. I don't have to touch hosts. In large part, we are at the point of not doing the large-scale deploys, really. This is a large-scale deploy in that my network's fully capable of supporting it. It's not a large-scale deploy in that we have a lot of hosts doing it. We're still figuring out how we're going to do a full-scale, live, real-world deployment. This is part of it from our side of figuring out how it works. There are an awful lot of interesting problems involving host registration. Our present system operates on a series of assumptions that get blown out of the water in half a second in IPv6. And the assumptions were never true, but they were true enough. Now they are simply not true. And nobody has a good answer yet other than 802.1x. Okay, so forklift all 5,000 switches in the organization and deploy PKI. I may have a talk for the next 2 years. Anyway, yes, sir. Yes. Okay, so from the back of the audience, we got Awk, and he's cheating because he actually knows how we do this. So this is another side which boils down to it's really hard to find tools that work right at the scale we're operating at. I have been looking at a number of them. I am looking to find one that actually solves my problems. I start with I have 100,000 MAC addresses registered. Start with that and see if your system can scale reasonably against that. Most of them fall on their face instantly at that move. Once you actually see the rest of the chain of things that have to interact with how these things are set up, it gets worse. So, yes, I'm looking for one. No, right now the solution is not Excel, because Excel didn't exist when we started tracking IP addresses. Our solution is, in fact, a several 100,000 line text file, awk, and a pile of carefully built integrated software that knows how to read router configs and synchronize them against the text file itself. So awk and a lot of homegrown stuff. There weren't commercial, open, or any solutions when we started doing this 30 years ago. Okay, so almost immediately, back to step in plus 3, people show up and say, we want IPv6. That's just like IPv4, right? Average time, it takes me about 5 hours on the phone with each group that shows up that wants to do this to make sure that they know enough about what they're doing that they aren't going to injure themselves. This is the logical equivalent of making sure you went through the training before skydiving. Okay, 5 hours on the phone, we get there. It's not IPv4, and we're going to do this a subnet at a time. Wait, I can't just get my one host turned on? No, I have to turn on the entire VLAN at once. Oh, I'm not interested. 3 rounds. Then we got a client. We actually got a first client to show up and say, yeah, we're going to do it. Okay, light it. We build out an entire test network for them. We light it. They had no testing environment when they started. They now get a testing environment. They're willing to work with us to figure out what's going on. We build out the test network. We built it on IPv4 and v6. They go and put some servers on it. Then they call me up and go, why aren't they auto-configuring? Because we're doing static. Okay, work through that. Did we win? Not really. IP addresses weren't pingable from the outside world, only campus. That was a router mistake on my part. This is part of the process that isn't getting solved yet. Client has intermittent problems communicating with the world, and in the process of figuring that out, I stumble into another, I don't have Slack enabled on this network. The client has a Slack IP address. Turns out the client decided to just look at other IP addresses and go, oh, that's how you do it, and actually statically entered his address as a Slack address. That's extremely confusing. Intermittent problems was ICMP and his firewall being blocked, thus blocking neighbor discovery protocol. No, really. ICMP matters. It's necessary to make your networks operate, and rather than it just being mostly functional, if in IPv6, if you block all ICMP, it's not functional. And this just snapped all the bits off. Please think carefully about it, and by default, leave it on. Okay, so how did it work at all? NDP was going provisional. Oh man, I'm out of time. See if there's anything else in here. I will go. We jumped through a whole bunch of them. We won. We made it to today. Throwaway test range. We're using a range we're intending to turn off in a year. So while we figure out how this works, it is a horrible address to type. We're not doing Slack yet. Use testing, get test environments, use maintenance windows, use rollback plans. Older switching hardware is going to bite us. We don't know when, we don't know how. It will show up. Registration systems are a mess. I can talk about that in some other context. And I'm out of time for questions, but I believe there's a question and answer room that I'm supposed to be hauling myself to if you feel like continuing this discussion. I'm heading that way, and I think Mike is as well. Okay, thank you all.